So hi, everyone. Welcome to this webinar. We're going to start in maybe 1-2 minutes just to give everybody a little bit of a chance to enter this webinar because we know that some people might have to install some things. So just waiting for a few more people coming in. We're very grateful that you're all joining this webinar, by the way. Very excited about it, about sharing this. Let me see. There are some more people coming in. And some more. Yeah. I think that should be good. Great. So everyone, welcome to this webinar, Predictive Observability with StackState version 4.6. We are very excited to share with you our latest release, and we're very excited to share this. And also, we're very interested in your feedback and any questions that you have. So my name is Annerieke, and today I am happy to share with you the presenters of today. They are, first of all, Lisa Wells, who is our product marketing expert here at StackState. Lisa will be gathering all the questions that you have during the presentation, so I will get back to that later, how to do that. Then we have Andreas Prins, who is our VP of Products. Andreas will give the presentation together with Mark Bakker, who is StackState's co-founder and product manager. So I think it's only one householding item that I have. So as I already said, we are very excited to hear your questions, any input that you have, and you can add those in the chat. You can see the console in the GoToWebinar control panel. And if you have questions, just put them in the chat. Lisa will gather all of these questions, and at the end of the presentation and the demo, we have a Q&A session. So make sure to put everything you have in there so we can gather everything and make this like a nice interactive session. So thanks again for joining, and Andreas, the floor is yours.
Yeah, thank you so much. And actually, we're here next to each other, so it's perfectly fine. Yeah, and we're really glad to have this webinar actually with you. And our intent is to make this a long-lasting tradition, which starts today, and really at the end of every release. And if we think somewhere in the middle, host more customer webinars where we can present capabilities that we've just delivered, but hopefully over time we can also share a little bit more about the forward-looking roadmap and all these type of activities, right, that are important to share. And just looking at the people who are attending, we met already, or at least I met some of you, so that's really nice, and definitely looking forward to meet more of you. So if there's anything that might have interest throughout the presentation, or where you have more detailed questions about, don't hesitate to reach out to me or to Mark to get much deeper than just this 45 to 50 minutes of the webinar. What we'll do today is actually go over the major items that we've developed in over the course of the 4.6 release, and we'll cover 4 areas. The visual enhancements will cover OpenTelemetry, and more in particular the capabilities we've added for serverless. We'll go over our latest AI additions, our autonomous anomaly detector, which really helps us to move more to the preventive area than we did before. And then there are some smaller but nevertheless super important additions that we're adding from a performance perspective, or simply from a couple cloud capabilities. And then last but not least, closing with our Kubernetes off-the-shelf beta program. And how we would like to approach it today is that Mark and I will co-present. I'll take the majority of the slides, and then Mark go from time to time to a demo. So you'll see us switching about 2 to 3 times between the presenters. Mark will jump in with me, and I will jump in with Mark when we think it's appropriate. All right, so going straight into the first topic. What we did is we've added quite a bit of small visual improvements, primarily based on customer feedback, that make the life of using StackState a little easier. And then primarily if you're in the mode of troubleshooting and you really need to go deep, how can you then use the UI or the elements we've added to truly understand what's happening and utilize the data and the knowledge that we've captured into our database. And the first one is what we call bidirectional dependency visualization. And this is super important because here we see a pretty simplistic topology, and I've seen the topology of many of you already in the recent months, and that's 10 times more complex. And then sometimes it's really hard to understand what is the dependency from this one single component towards my other components. And what we've added are these little dots, or what we call the moving dots on the line, that actually show you the dependencies. And that helps you to really see in one glance, how is this component related to the other ones by showing up and downstream dependencies. And then if a particular health state goes into deviating or into critical, we start coloring the dots as well. So it's really helpful as a visual instrument to see how the dependencies are shaped. And that's kind of the first step for you to know where to look at. Then the second addition that we've added is the ability to really quickly see the indirect relationships, because all of you know that between two components, we sometimes filter or hide all the components that are in between. So actually the path from one single component, the front end, towards the order component in our topology. And we do that to simplify the view. But sometimes, and again, in particular with troubleshooting, it is really important to understand what is happening between these two components. We visualized that in the past with a dotted line, but now you can easily click somewhere on the dotted line and you'll get on the right-hand side panel an overview of all the components that are in between the front end and the orders. And that is super helpful because then you can see, hey, are there ones that are impacted or whatsoever? And if you want to go deeper, you have the ability to go straight towards a subview where you see the dependencies between, or the entire diagram, if you like, or the entire tree of these components. So that's another, well, you could argue minor addition, but really helpful to go fast in troubleshooting by building this direct understanding. And again, the more complex a topology gets, the easier it is to have this capability at your fingertips, because then you can go pretty fast towards what you want to see. And then the third element that we've added is, oh, by the way, here you see that if a component, or in this case, the propagated health is critical, you see that the moving dots turn red. So that's a nice addition. But the third larger visual improvement we've added is the top metrics in the context of where you are. So normally, or in the past, I would argue, you need to go towards your right-hand side panel and take a look at the metrics. They were a little down, so you had to scroll. And what we really have added is, as soon as you hover over your component, we immediately pop into your face the top metrics. And you might ask, hey, what are top metrics? For the ones that are familiar with StackState, there is an algorithm in the back that determines the metrics that are of the highest priority. That's set in a stack pack and based on a couple other parameters, and that together will bring you up the metrics that are the most important at that moment to look at. And with these three, we're really bringing the UI a step further to help you understand how to use, how to troubleshoot, and get a better grip on what's actually happening under the hood of StackState, or actually under the hood of your landscape, because we're just visualizing the landscape that you have in your company. Then, how do you use this capability? Well, it's super simple, nothing special for these three improvements. It's just part of the regular package. So whenever you upgrade to the latest version 4.6, you'll get all these capabilities straight away. No configuration or whatsoever is required for this. All right, moving then to a, well, I would argue a much bigger topic from the new capabilities that we're adding. The other ones were kind of important, but
should we not
small
demo
improvement.
them, Andreas?
Sorry?
Should we not demo them?
Yeah, sorry. Great idea, Mark. Thanks. So let me make you presenter. So we'll switch over to you, and then let's see how that actually looks like in reality, in practice.
Okay. Yeah, you just saw the static picture. if you now hover on a component, you directly see the top metrics, and as they update in real time, you see them changing. So in this case, those are metrics about my active MQ broker. What you also see in the background is the dotted lines, and see how they easily show you how the dependencies lay and in which directions they lay. And also, if you want to see it indeed, if there's a problem, you directly see also the color coding of the fact that something is in a critical state. So that's one and two. Then the other one, seeing the indirect relations. We see here an indirect relation between two services. So in this case, oh, sorry, my control for the webinar is in my way. So in this case, we see here a front-end service, in the end talking to an other service, with in between a certain pod, a certain container running the process, a certain process basically serving the code, and in the end calling another service. And if we want to see this dependency, we can easily click on investigate subview and see this subtree of all the services and other components which are in between. So let's go back to Andreas.
Thanks, Mark. See, it's the first webinar we're doing together, so we're also still a bit practicing to do this together, but we're good there. All right, so the second topic we would like to go in is the support of OpenTelemetry, and then more in particular of serverless Node.js. And this is a capability that we have developed with one of our customers in close collaboration. Just setting the scene a little bit, there was a team that was developing AWS serverless applications, and they really would like to see the topology reflected in StackState, so they can use the holistic perspective of StackState to understand how all these services interact with each other. And well, it's a fresh modern team using modern technology, and they also decided to use OpenTelemetry to augment their applications with metrics, traces, and logs. And then the question is, how can StackState help us out there? And really what we did is we developed this capability to retrieve the data and start handling with it. So let's take a closer look at OpenTelemetry and what we actually delivered. So here I mentioned a team developing serverless applications, and what we really discovered is that all these components, in particular in a serverless environment, they come and go, right? It's not a static landscape that you're looking at, not even a static of microservices, but it's even more dynamic. And in particular in this dynamic environment, the team concluded that to do proper development of their capabilities and troubleshooting whenever something goes wrong, they need something where they could visualize how the services relate to each other, as well as they need the ability to travel back in time, right? Because if services come and go and you need to troubleshoot, that is a really important element to get covered. So really providing the insight how the components are connected for the development part and the troubleshooting after something is developed and running in production. And what we did is we embarked on the journey of OpenTelemetry. And for the people who are familiar with OpenTelemetry, it's quite it's quite a large open standard to do metrics, traces, and logs. And you could argue that the entire cloud native application development is really embracing OpenTelemetry, a standard that's growing in the last few years and really, at least in this area, becoming more and more mainstream. So for us, it is also important to start supporting this capability. But if you know the OpenTelemetry standard, it's quite broad, and some languages or some specific technologies have their own particular implementation. So we said with these customers, okay, let's start somewhere. And in particular, let's start supporting them. So AWS serverless, and then even more in particular, a Node.js application. And that's where we started, and that's what we provided. And what we do is we analyze these traces and we infer out of this topology to really understand how components are related to it, but also the three golden signals: throughput, latency, and error rate. And in particular, this is important, right? Because then you start observing how these components behave in production, and you can take your lessons, optimize, and learn from that. And really, if you combine these OpenTelemetry traces with our existing AWS cloud infrastructure through the AWS Stack Pack, that provides, or that gives you the holistic picture where you see the AWS component and then on top of it, the serverless components that the team was developing. In this case, saturation, the fourth golden signal, was not part of the development because the information can simply not be collected through traces. So for us, it was really the first step that we made. And Mark will guide you through how that actually works. But before going in there, let me make one side note. We're publishing in about a week a nice video of 15 minutes that really goes step by step through how you implement and how you get the value out of OpenTelemetry trace information. And this is a condensed summary of it.
Yes, thanks for that. We thought it's much better to show an extensive walkthrough for this and really show off what we can do, what value we can add, and how it works. But it takes a little bit more time than in a customer webinar like this. But in this case, what we have here is an example application, an IoT application. What you see on the left is there are some IoT devices. They basically gather information about the temperature, about humidity, and about your air quality. And all the data is sent to an AWS Lambda via an API gateway. And the AWS Lambda sends all the data to the 3 different queues. There are 3 other Lambdas listening to those queues. And one of the Lambdas is also calling out to an external API to get the weather conditions. Based on that, the data is processed, it's sent to an RDS database, and some alerts are sent out on specific weather conditions or predictions. So it's quite a simple application to do weather predictions and alerts on certain conditions. So maybe you can go to the next slide, Andreas. With StackState, only with the AWS Stack Pack, we can discover basically all the servers, all the Lambdas. We can see how they are behaving. But what we cannot see is how they are communicating with each other. So what we did is adding the OpenTelemetry support, a layer on top of your AWS Lambdas, which can be installed very easily. And with that, we automatically detect all the traffic flowing from the different Lambdas to the different services, all the queues connecting to each other, and so on. So if we see on the next slide how that looks like. So in this case, we see the different Lambdas connecting to each other. But what we also see is that there is an error. So we see that we automatically detect the topology. We also automatically detect the traffic, the golden signals, and all the errors. And if there are errors, we can quickly see what type of errors there are. So you can quickly troubleshoot your application. Next slide. Next to the topology perspective, we also support a trace perspective. In the trace perspective, you see the different traces. You can see all the details of different spans. So basically, if one component talks to another component, it's 3 different spans. The upper one is the higher level span, the green one in this case, and the lower one, the purple one, is the span below. Each span is a call to another service or to another Lambda or to a step function. And each call also has a lot of details. So you can see all the different parameters setting there. You can see how long it takes. You can see if it's an error. You can see the protocol being used, and so on. And you can see all the telemetry for the different services and spans. Next one. For the OpenTelemetry supported traces, obviously you can also use the telemetry perspective to see all the different components together and see the most important telemetry for all those components all at once. That concludes basically my very short introduction to what we can do with OpenTelemetry, and I would really recommend reading our blogs, which we will post in the upcoming weeks, and watching the movies, which will be part of that. Back to you, thanks, Andreas.
Thanks, Mark. Then indeed, as Mark said, video, blog post, all these stuff coming up mid-April as they're scheduled right now. Important to know how to get it up and running. It's stated here, upgrade the agent to the latest version, install the open serverless layer. You can retrieve that from an S3 bucket, and then obviously configure your Lambdas to use the serverless layer. This is all documented on our documentation page, on our doc page, and you'll find links in the release notes to get yourself familiar with this. This is really a new journey for us. So if you're having a team that is also using OpenTelemetry in your company, absolutely don't hesitate, reach out to us. We really want to understand how you're using, what you're using, but more in particular, what is the problem that you're trying to solve. And if you can reach out to us and provide us that information, that's helpful for us to continue the journey that we are starting with OpenTelemetry. All right. Then moving on to the other big topic, and that's the enrichment of our AI or AIOps capabilities, if you like. But more in particular, the ability that we're adding is what we call preventive checks, really helping you out to prevent failures that are happening in your company by observing anomalies in your telemetry streams. And that's what we've added with the 4.6 release. And we're pretty excited because this is helping companies not only to detect issues, to reduce MTTR, and to do great troubleshooting, but this is super important because this is moving you forward. And even before a customer is impacted, you actually can detect what is already happening and what might potentially cause an issue a little later in time. So what is the autonomous anomaly detector? Well, it's a capability, an AI capability that finds potential problems. And this is important to understand. It is not necessarily already a problem from a customer perspective, but we really try to detect, as said, the anomaly and then take action. It helps you to pinpoint the root cause of a problem, because sometimes a root cause, right, or an issue does occur, and then an anomaly might be the foundation. So a component might be still okay-ish, but then if an anomaly has occurred a little while ago, this might cause. And what we help you to do is to pinpoint the root cause of the problem. The good part is there's zero configuration required, and also no knowledge to get this AI module up and running. And we've really focused on getting as fast as possible value out of this anomaly detector. So also the time that the model is learning is super short, and Mark will elaborate a little bit on that while demoing. Then we find anomalies in the first place in the metrics that are sent out to StackState. That's how we do through the agent. But in the second place, and that's also important, is we also have access to other metrics coming in through CloudWatch, Prometheus, Splunk, and you can apply this anomaly detector also on these streams. So it's not only for the agent or Kubernetes or the capabilities that are off the shelf, but it's also for all the telemetry streams that are flowing through the system and where you want to detect anomalies on. So in the past, right, I would say, or as we speak, many monitoring and observability tools, they actually respond as soon as something happened, right? So not necessarily directly an incident impacting the customer, but there's something going wrong with a particular component, it's hitting a particular threshold, and then you want to act upon it. DevOps teams looking for suspicious behavior, where are they looking at? Well, they look at golden signals. And then in particular, they look at anomalies, right? Weird spikes in particular streams, and then they know, hey, there might be something wrong, but how can you deal and how can you handle that if you have tens and hundreds of components or thousands of components going on? You're not able to have your eyes on all of these streams flowing through your system. And that's exactly why we believe a little bit of automation is needed to keep track of all these streams. And that's why I've developed this AI anomaly detector. So Mark will show in a minute how it actually works, but really with StackState 4.6, we turn a wheel and we go to proactive monitoring. We auto select the most relevant metric streams where we think we need to apply observing the golden signals. And then we automate monitoring these streams. So we adapt to metric streams in real time as said, no human eyes needed, right? It's not that, hey, I do think this is a risky area, let's tune it and let's start doing anomaly detection on these streams. No, that's what the system takes care of. There's also no threshold tuning, and it's truly autonomous. And then important, we'll see also in the demo, is we group suspicious behavior with potential causes, because detecting an anomaly is just a first important step. But if you detect an anomaly without context, without knowing which tree all the way up it impacts, or what are the neighbors or the downstream dependencies, it's just an anomaly. So what we do, because we have the ability of correlating stuff towards each other, we really bring you the golden, or we really bring you these anomalies in the context of where you're looking at. And also more about that in the demo. And I would say let's go over to the demo, and then Mark can show actually what's how it's behaving and what's happening there.
Sure. Okay. So in this case, let's go to back in time, because with StackState we can, and it's easy for me to demo because I know that at some point there was a certain situation. But obviously, I know it now, but I could also have known it because there was just an alert sent out. Previously, when we had anomalies, alerts were not sent based on them because we always want to have a certain amount of trust in how good those anomalies are. For the service detection now and for the anomaly detection on services, we really think that we are at a level that we can basically alert proactively. So what we see now here is a landscape where at the right we see that there is a problem. And the problem states that it's caused by an HTTP 500 error rate check, an AAD check, an anomalies detector, autonomous anomaly detector check. So let's have a look at that orders component. If I click on it, I now see the check, and I also see that's in a deviating state. If I click once more time, I see that there was an anomaly here, a huge spike, as you can see indeed, which might have caused a problem. If we now go back to the problem and we click on the problem, we also see what are the probable causes. In this case, we're still working on augmenting the algorithm to find the best probable causes. In this case, in the top 10 of probable causes, I will find the change which leads to this failure. And in this case, it's a configuration change which has been done by deployment, and basically that's the cause in this case. Yeah, I think that concludes my demo. Did I miss anything, Andreas?
Yeah, what would be interesting, Mark, if you can share a few words on the learning time that it takes to get this anomaly detector up and running in your own environment. That's one question. And the other question people might have is, hey, this is nice for some out-of-the-box capability StackState delivers. How do I apply it also on my own streams?
Sure. Yeah, first of all, the more data we have, the better the detection will be, because if you don't have context about strange behavior, you cannot alert on it. But basically, if there is 3 hours of data, it can already do its work and find huge spikes, for instance. And the more data we have, the more value it will provide. Then the second question, what was it again, Andreas? Sorry, maybe could you repeat it?
Yeah, that's fine. It's working on some of the standard out-of-the-box component we ship. But what about if I want to start applying it to my own streams?
Yeah, that can be done. So out of the box, we ship our Kubernetes stack pack, for instance, for all the services with autonomous anomaly detection enabled. But basically, the autonomous anomaly detection checks can be added to any service and that's or any stream. So that can be done by adding them via the stack pack. Oh, sorry.
Okay. So it's actually applicable to any stream going into the system, and for the Kubernetes one we ship, it's out of the box available.
Correct.
Excellent. Thank you so much. Let's continue to the presentation. Let me know if you can see the right screen.
We can see it, Andreas.
All right. So to get this up and running, there's a little more work to do than the first one, but still easy to get there. Upgrading the agents, the Kubernetes stack pack, and also the AAD stack pack. It's included in version 4.6. And then last but not least, obviously, enable the autonomous anomaly detector stack pack. It's a mouthful of complex word, but we'll get there. And again, also for this capability, we just started the journey to push this to the next level. So if you say, hey, this is super important, and I'm, for example, looking forward to use this in my master control room or in my operations team, please reach out to us, because this is super important for us to get the feedback. There's a dedicated team working on these capabilities, and all the feedback we receive is super valuable to push it to the next level and the next level. So yeah, reach out after the call. Most of you have our email addresses. So yeah, we really hope to find design partners also to continue the development of this capability. All right, then let's move on. A couple, well, not smaller ones, super important ones, but we've grouped them under a additional enhancement bucket, is the performance improvement. So from 4.5 to 4.6, we focused quite a bit on the topology synchronization. Sometimes with massive topology updates, StackState was, well, not keeping up all the time, so dropping sometimes a little bit of data or causing some latency issues, and that's what we improved. So in short, the topology synchronization has a performance improvement at least of 6.2 measured from our benchmark environment. We've also other measurements. If you combine it with the measurements we've added in 4.5, it goes way beyond. So hopefully this is yeah, super helpful for all of you who are running StackState at scale and dealing with topology synchronizations. Again, also on this topic, don't hesitate to reach out and to provide any more feedback on this. And then the last element that I would like to touch upon today is the additions of Containerd and CRI-O, the container runtime that we've added for OpenShift, CRI-O, and for regular Kubernetes, since Docker is no longer kind of the recommended runtime for Kubernetes. So we've added these two runtimes to be supported out of the box. So if you're using it, well, we're safe and good to go, and also harvest all the data that is required to these runtimes to provide you the visualizations and to provide you the insights and the capabilities that we have with StackState. For this one, again, pretty easy. Just upgrade it to the agent v2, the latest version, and we'll get these capabilities straight into your environment. All right, and then at the title slide or the content overview, you've noticed that there's actually one more topic. I've listed it under the bonus. The bonus, not necessarily from a capability, but really for this webinar, and that's what we're doing with Kubernetes. Most of you know that we're already quite a while on the journey to support Kubernetes. Many of you are already in there, and what we've noticed that some of our customers are struggling a little bit to get the Kubernetes environment up and running themselves in a stable manner, and then having a hard time yeah, to run the Kubernetes environment, not necessarily StackState, but really the environment. So what we said is, are there solutions in the market that we can start using to help out our customers really to have that smooth operations of our system while we're moving more and more towards Kubernetes? And that's why we selected COTS, Kubernetes off the shelf. A couple of you are already with us in this journey. It's all at this moment in beta, and throughout the course of the next 2 to 3 months, we really want to push it towards a level that it's GA, that we know how to tune it in detail, that it's well documented, and that it's monitored and observed, so we have a stable, robust, and reliable environment to run StackState on Kubernetes. So if you're looking into this, if you're wondering, hey, how might this go? Again, please reach out to us. There's still room enough to help you out getting up and running on COTS, and for us, that's again really valuable to get this data towards us and push the product further. All right. In short, what we've seen today are the enhancements that we've made towards StackState version 4.6, and they primarily reside around 3 topics. The visual elements that we've added to enable you to do faster troubleshooting and build a quicker understanding of your landscape. We've briefly touched upon the OpenTelemetry support, and then more in particular, the serverless Node.js support that we've added, and all the capabilities, all the data that you can retrieve through these traces into StackState. And the last item we've touched upon was the autonomous anomaly detector, really helping you to move forward from a more reactive detecting issues towards a proactive mode of operations that help you to prevent failure, and ultimately that will help you to provide a better customer experience. So for all of this, I can imagine you want to do a deeper read. There is the 4.6 release post already on our website, 4.6, harnessing the power of topology telemetry traces. And there is a business blog, I would say, business blog post, really covering why OpenTelemetry is important, what are the movements going on in the market. And then coming soon, there's a second OpenTelemetry blog post really focused on developers that want to get familiar with OpenTelemetry and potentially even start trying it out in conjunction with StackState. And with that, I do feel there's still plenty of time for questions and answers. So Lisa, over to you.
Good afternoon, everyone. Good morning. Thanks very much. We've got some great questions that have come in. And I will start with one about the autonomous anomaly detector. Does it monitor golden signals only from StackState stack packs, or is it applicable for any metrics sources like Elastic?
It's applicable for any metric. So it takes the highest priority metrics on the most important components that are important for you as a user.
Great, thank you. Which leads into the next question. How are those streams determined?
Those streams are determined by the priority of the streams as they are set in the stack packs, and also by taking into account which views are start and which parts of the topology are used the most.
Great. Is the autonomous anomaly detector capable of predicting monthly patterns? For example, salaries are paid on a certain day. Thus, there is increased traffic and customer count. This doesn't mean a problem if monthly analysis is done, but it might be a problem if it happens on a certain day.
This is part of our roadmap. It's not yet supported.
All right.
But it's really a good question, and we'll follow up on that. Lisa, do you have the name of the person who asked this? I'm imagining, and we'll follow up because this is interesting to see. Hey, what is next besides anomaly detection, kind of on a short time window, right? What are the monthly type of things or other patterns that we would like to detect? Yeah.
On that roadmap line of questioning, the OpenTelemetry trace support for serverless is a great development for a modern DevOps team. How does StackState plan to continue this development?
Yeah, I'll take that one. I briefly mentioned, right, in the presentation that OpenTelemetry is quite a bit of a journey, right? It's a large standard that is rising, and well, some technologies take a specific implementation. So what we've done now is really focus on this serverless Node.js application, and our next step is to actually do a step back closer to the standard and just start supporting OpenTelemetry traces. So that will be, or that is the slice that we are working on in the current release. So if you are using this, or you have a DevOps team somewhere out in your company that is developing this, please let us know. We would like to do that together. And then we've covered traces for a narrow technology specific, and traces from the standard perspective. And then the next step will be metrics and logs and all the other capabilities that are in that standard. But yeah, that's about the journey that will take a couple of releases, but really making steps into that direction.
Thank you. Circling back to autonomous anomaly detection, what if we don't set the priority on the top streams? What streams does it monitor then?
It will take all the available and assigned capacity to take the most important streams, and streams always have a priority. So it will take the most important streams anyway. But if they are not set by the stack packs at all, it might be quite random.
Great, thank you. How do I make sure autonomous anomaly detection isn't using too much computing power?
Basically, the amount of computing power from a CPU and memory consumption perspective is something which is set, and then it will use all the capacity which is available to process the most important metrics and the most important parts of the topology.
And how about accuracy? How many false positives can we expect?
Yeah, we really focus on this feature to make sure that we don't have too much false positives. So our aim is at least have less than 20% false positives, but I think we are above that.
And again, it's glad someone is asking. Again, this is right. This is based on quite a bit of data sets that we've used to train the model. But also here, it is super important to get your feedback and actually see in your real life situation how that goes. So if you start using it, please involve us. The beauty of how we implemented it compared to just doing anomaly detection on a single telemetry stream is we always do it in context of the bigger whole. So we will report it into probable causes of potential issue that is happening, and that helps you to understand it much better from the context where you're looking at, rather than just having single alerts going on and off in your landscape.
Let's see, moving on to UI. Thank you for making these UI improvements. That will help a lot of people to start using it. For people who are new to the UI, it sometimes still takes a while before you understand what you see. Is StackState also having plans to improve the UI even further?
Yeah, that's always a challenge, I would say, for StackState, right? And not necessarily for StackState, but for companies in general, because they grow these landscapes pretty complex, right? That's IT, right? Tens, hundreds, thousands of components. So how do you then deal with that? And the UI, visualizing that is important, and there are many capabilities to simplify that. As we speak, right, we're doing we finished a piece of research with people who are super new to StackState or even unfamiliar with StackState, and take the lessons learned there. And the goal there really is to do a big overhaul of the UI. So you might expect in the upcoming release a change of how it looks and feel. But also important, we try to really understand kind of how people behave while using the UI. And the analysis we executed is, what do they understand of what they see, even without clicking on a single component? And these lessons will be incorporated in the upcoming release. And the goal there is to lower the cognitive load that people will have while entering the UI. And then, we make a big step in 5.0, but also we take many lessons towards the releases afterwards.
Thanks, Andreas. Sorry, Mark, go ahead.
Any more questions, Lisa?
Let's see. I think that's it, unless we'll give people a little more time to enter any more. Wait, one more. How do I make sure the autonomous anomaly detector is not using too much compute power?
It sounds like a question I just answered, but let me answer it again. Anomaly detection basically takes into account the amount of capacity you assign it to it. And based on the capacity you assign, it will take the most important streams and the most important bits of the topology towards.
So you ring fence actually the amount of compute and whatever that anomaly detector can use, right? And then determines him or herself. We haven't given it a name yet, so we leave it in the middle whether or not it's him or her. that machine determines itself, right? Which streams it needs to observe.
Correct.
Are we taking feedback for the name?
That's a good question. We can think
You
about
can
that.
always send in the feedback and we will see.
So on that topic, we would love to hear your feedback. As Andreas said, good feedback, bad feedback. I will share one that came through in the questions. That's not really a question, and that is, I really enjoy bidirectional dependency visualization. Makes life much easier when showing something to colleagues. So thank you, we appreciate that.
Thanks for that.
Yeah, Andreas and Mark will share how to reach them. You know, I'm sure you can find all of us also through your customer support team. Love to hear your thoughts and what will help make your life better going forward.
Excellent.
Yes, I'll chime in again. So thanks everyone for joining this webinar. Thanks Andreas, Mark, and Lisa for giving the presentations and answering the questions. So I think everything has been said. Just so you know, we will share the PDF of this presentation, so the slides that Andreas shared with you, so you will receive that in your inbox, and also the recording of this webinar so that you can watch it again or maybe share it with your colleagues if you want to share the new things that are going on in StackState. And again, we really like your feedback on everything that the team has been working on. So we really appreciate that. And thank you for taking your time to join us today, and have a great day, and see you next time during our next webinar.
Thank you.
Bye,
Thanks
everyone.
for joining.
Thank you. Bye.